Hey guys, today we're going to learn about evaluating and solving logarithmic functions. So let's start with the definition of a logarithm. So for all real numbers y and all positive numbers a and x, where a is different than 1, we have that y is going to be equal to log base a of x, and this is equivalent to the form x equals a to the power of y. So we call this the logarithmic form, and this we call it the exponential form. Why we call it this way? This one has a log and this one has an exponent. Okay, so the expression log base a of x represents the exponent, okay, to which the base a must be raised in order to obtain the value x. So the table that we have over here, let's see it, shows several pairs of equivalent statements written in both logarithmic form and exponential form. We need to complete the table. So if you have this equation, okay, and we know that the base is 2, how you can rewrite this in exponential form is 2 to the power of 3 is going to be equal to 8. So as you can see, what I do is this 2, it's going to be here and then raised to the 3, okay? So what you have here in the next one, you have that the base is going to be 1/2, okay? And the exponent that you have is going to be -4, okay? And this is going to be equal to 16. So please note the pattern again, okay? This 1/2, it's going to be raised to the power of -4, and this will give you 16. Okay, so look at the pattern there. Similarly here, what you have is going to be pretty much the same. You know that it's going to be base 10, okay, to the power of 5, and this is going to be equal to 100,000, okay? So hopefully you see the pattern there, and this is a comma, okay? I just made a comma huge, okay? So now doing it backwards, well, here you have the exponential form. How can we convert this into logarithmic form? So the base is 3, so I start with my log base 3, okay? And what I'm going to have inside my log is going to be the 1/81, okay, and that's going to give me equal to -4. Okay, so as you can see, this one is the base, okay, this one is what you have inside your log function, and the -4 is your result. Okay, so let's look at the pattern here. You have that it's going to be log, and it's going to be base 5 from this one, of 5 of this 5 is going to be equal to 1. Now what happens here? You have the exponential form. Since we have the exponential form here and we want the logarithmic form again, you want the log base 3/4, okay, and what you're going to put inside is the 1, and that's going to be equal to 0, okay? So that's for that one. Now this one that we have over here, you have log base 4 of 16 is equal to 2. So what you're going to do again is you take 4 to the power of 2 is going to be equal to 16. Okay, that's the exponential form. And last but not least, you have this 7 to the power of 1 is equal to 7. Well, that one is pretty similar to the one with 5s that we did before. So you have log base 7 of 7 is going to be equal to 1. Okay, so we're going to evaluate each equation. Okay, so we have log base 3 of 81. Okay, so what are we going to do? Well, what I'm going to do here is I'm going to equalize this to x. Okay, clearly this is in logarithmic form, so what I want to do is pass it into exponential form. You know that in exponential form this is going to be 3 to the power of x. This is going to be equal to 81. So you need to ask yourself, what to the power of 3 gives you 81? So that one would be 3 to the power of 4. Okay, so using exponential properties, you know that x is equal to 4. So what do you have? You have thus, okay, log base 3 of 81 is going to be equal to 4, okay, and that's your evaluation, okay. Another way to ask yourself about this type of questions, you can ask yourself what power of 3 will be equal to 81, and that one is equal to 4. Okay, so the next one that we have over here is not as trivial. Okay, so you have log base 4 of 8 to the power of negative 1. So I'm going to equalize this to x. Okay, then I'm going to move this logarithmic form into exponential form. So what you have here is 4 to the power of x is going to be equal to 8 to the power of negative 1. And you're going to tell me, I cannot raise 4 to have 8 as my result. That's true. But you know that 2 squared is 4, okay, and that one is an x, okay. And then you know that 2 to the power of 3 is 8. Okay, so as you can see, this is 4 and this is 3. So what are we going to do here? You use exponent properties, and you know that 2 to the power of 2x is going to be equal to 2 to the power of negative 3. Okay, having this, you have the same base here, so you can equalize 2x to negative 3, and this one, I'm pretty sure you already saw that this is x equals negative 3 over 2. This means that when you evaluate log base 4 of 8 to the power of negative 1, this is going to give you negative 3 over 2. Okay, so for this problem we have log base 6 of 36 root 6. So what I'm going to do here, I set this equal to x. Then you pass this logarithmic form into exponential form. Having 6 to the power of x is going to be equal to 36 root 6. So what you have here is something with patterns of 6. Okay, so 36 is 6 squared, and root 6, you know that it's multiplying the 36, and it's going to be 1/2. Okay. Now, using exponent properties over here, what we're going to do is you have that 6 to the power of x is going to be equal to 6 to the power of 2 plus 1/2, which is 5/2. From here, you know that x is equal to 5 over 2. Therefore, what can you conclude? Well, you can conclude that log base 6 of 36 root 6, this is equal to 5 over 2. Okay, so that's what we have for this one. Now, for the next one that we have over here, you need to solve each equation. Please note that here you need to solve. Okay, so you have log base 3 of 7m minus 4 is equal to log base 3 of 5m plus 2. So what are we going to do here? You recognize that the base of both logs are the same, and I only have one log on this side and one log on this side. So what we can do in this case is we can equalize the inside of the logs. Okay, so we can equalize 7m minus 4 to 5m plus 2. When you have this expression, you know that we can pass like terms together to the right and left side. Okay, so I'm going to pass the m's to the left side. Having 7m minus 5, you know that that's 2m, and then 2 plus 4 is going to be 6. Okay, then you divide by 2 both sides, so you have that m is going to be equal to 3. Okay, so your result here is going to be 3. Okay, so on the next one that you are going to have here, well, you don't have the same situation. Okay, so we have log base 4 of x is equal to 5 over 2. So what are we going to do here? You see the logarithmic form. I'm going to pass this into exponential form. Okay, so you know that this is going to be 4 to the power of 5 over 2. That's going to be equal to x. And moreover, you recognize that 2 to the power of 2 is 4. Okay, to the power of 5 over 2. Okay, which is the same as this one, that's x, so you cancel out this. So what you have is that x is 2 to the power of 5, which you know that it's 32. Okay, so x equals to 2 to the power of 5 is 32. Therefore, your result here is 32. Okay, now for the last one that we have over here, what we have is log base 49 of cube root of 7 is equal to x. Okay, so what are we going to do here? Well, what we can do here is you can again pass this into exponential form. Okay, so you have that this is going to be 49 to the power of x is going to be equal to the cube root of 7. Okay, so what you recognize here is that 49 is what? 7 squared. Okay, and you know that cube root of 7 is the same as saying 1 over 3, okay, the power. Okay, so what do you have here? You have that 7 to the power of 2x is equal to 7 to the power of 1/3. Okay, so from here you can see that I have this 2x is going to be equal to 1 over 3. Okay, so and when I pass this to dividing, I know that x is going to be equal to 1 over 6. Okay, so your result for this one is going to be 1 over 6. Okay, and that's it. Hopefully this helps you to learn better how to evaluate and solve log equations.